Um, During the coming section, myself, Gary Lee, together with the Red Hat Brain Compton, senior director from the Red Hat storage team, and also Kyle Bader, senior architect from the Red Hat story also. We'll share you the one of the very good testing that we did for the last year and continue to the this year. That is actually the very good use case to using the Ceph for the big data analytics. Before we doing that, probably let me go over the some of the history that Red Hat together with the QCT, the core engineering journey. Actually, back to around the 2015, so 3 years before. We actually met in Boston, if I'm not wrong. Actually, some of the discussion between two companies. QCT is a company that's strong in the infrastructure hardware. Red Hat is one of the outstanding company in the infrastructure software. So we're discussing about what is the the collaboration, and also what is the eventually the overall the offering we can work together to the customer. So starting from there, we choosing the Ceph storage as one of a very important collaboration item. You probably know that the Ceph is from his architecture is quite a very brilliant as a cover different targets, so it can provide for the object storage, can provide for the file, it can provide the block. So from that then, discussion is all around how we can do for the customer. So from the customer point of view, this the key point that we call develop the solution. So among the 3 years period, actually starting from the throughput, going to the capacity, and then go into the IOPS for the some of the transaction base of the use case, and end up we went into the big data, which is the alpha that we did last year. And using the Ceph for the different I would say that the different use case and see the how eventually the Ceph architecture can bring the benefit to the different use cases, all the works that we collaborate during this period. And also starting from this year, we also moving up the collaboration to the file, which is I think is a lot of the expectation from the enterprise market. So pretty much that's the key thing behind two company. So talking about something about the Ceph, you'll see that I covered that already as it can provide the object, block, and the file. That's versatile. The nature can help it to leverage into the different use case. So last year we found the big data, which almost the key topic and the hot topic for the enterprise. But if you ever get involved into any big data project, you probably will know that the big data, although that it's a hub, that but from the practical point of view, it's got a lot of the different tool chain. So you see a lot of different extraction method. You see a lot of different analytical engine. You see a lot of the method eventually to sort and organize the data. So which means that the huge set of the data, you always moving around the different tool chain. Sometimes that you get in this engine for analytic, the other engine for other purpose. So quite often you move data around the different portion. So cause a lot of the challenge for the big data scientists. So we discuss and see the nature of the safe storage I mean, that's the versatile, the nature of the Ceph storage, how it can help. So that kicked off the collaboration between us. Before that, you probably can take a very quick look at so far that all the skill that developed here is based on what I mentioned of different use case. Some of them is for the streaming use case. Some of them for the big archiving case. Some of them is for the OLTP mission critical kind of the application. And Ray Hay and QCT end up work out with the skill to meet for the different use case. So the project that we did is actually using the Hadoop. Hadoop, the popular, the structure using the hyperconverged, you probably know, right? HDFS, the store, and actually you bring the data into the HDFS. That's distributed in nature, but as I mentioned, moving around the different analytical stage, it actually causes a lot of the trouble, and you always copy data from here or there. The big data nature keep you very, very unproductive, for you moving data around. So using the Ceph, that's as the common data lake. That's the effort that we work with the Ray Hay. So later, we'll go over some of the architecture level of the sharing, and also using some of the real customer use case as an example to share with you what we have found there. Let me pass the section to the.
Thanks, Gary. So, question for you, those in the room here. I mean, you're welcome to answer it, but you're welcome to also leave this rhetorical. How do you POC at scale workloads at scale? And that's a tough thing, and quickly. You know how it normally goes. You know, a customer says, "Oh, I love this idea. I love the idea of this. This solution you're discussing, proposing." But it's an at-scale workload. Sure, I can run it on a toy, couple of small server. But this is, I need to see if it will run at scale. That's kind of the problem that we are focused on addressing with what Gary talked about. The last bit, his last slide, he had a word called Tricep. And Ceph is for scalable object storage for petabyte, decapetabyte, 100+ petabyte type deployments. How do you POC that at scale with reasonable workloads? So, and quickly, you know how it is. You're working with the customers. The customers say, "Oh yeah, sure." As soon as we get through our this committee and that committee and the other committee, in about 12 or 15 months, we'll be able to get the equipment required to do this POC. Right? You've been there. So this is the QCT being the effectively the most popular at-scale infrastructure company. It makes sense that QCT would have labs for POCing workloads at scale. They are the at-scale infrastructure company. So Red Hat, together with QCT, have done exactly this with large kind of Fortune 100 type companies who want to POC their at-scale workloads at scale inside of the infrastructure of the world's largest at-scale infrastructure company. So that's what this is about. So what problem did we set out to solve? So it was this one. Customer said, I have a large-scale data analytics pipeline, from ingest on the left-hand side all the way through to machine learning on the right-hand side. Great. I'd like to run this because back in the day, this workload, back in the day, this workload, this pipeline was fine. I had a couple of guys in the back room messing around with Hadoop on a cluster. But my problem is that was 10 years ago. Today I've got many teams of data engineers, data scientists, data analysts. So I have a bunch of different teams. And when they're sharing the same infrastructure, it creates congestion. Congestion equals people having to tell their boss couldn't get the analytics completed in time. So what happened was I said, okay, so the usual case, get a bigger hammer. That was one solution. and some of our customers tried this. So the second solution is give every team their own cluster, but the problem there is there's no shared data context. We have some of the customers saying, listen, these are tens of petabytes. If I have, let's say I have 20 different standalone clusters because every team needed their own cluster, really I'm going to replicate 20 petabytes times 20 clusters? Yeah, that was both CapEx as well as OpEx-wise unacceptable. So this was the problem that we set out to solve with some of these customers in the Tricep QCT POC lab. It was number 3. Multi-tenant workload isolation with shared data context. Give the ability effectively to, in this case, run multiple Spark clusters. So some team need core and RAM-rich environments. Some teams just running traditional batch jobs need fewer cores and less RAM. So every team could have their own effectively hardware profile for the compute side, but they need a shared data context. That was this was the Tricep lab that we did. So Kyle's going to talk a little bit from the workloads that in a couple of these different paid POCs that were performed. Range from, on the one end, from batch ingest through different type of query analytics, merge, join, ETL, etc. So this was the workload profile. Again, it's somewhat analogous to modern data analytics pipelines. This was the workload. So Kyle's going to talk to you a little bit about the Tricep solution architecture with Red Hat, and just give you a peek about the results.
Great, thanks, Brent. So kind of the building block we used for the shared data context here is this particular server from QCT. 4U has 2 servers in it, and each of them has 35 drives and a couple add-in card NVMEs. We configured these as the Ceph storage hosts to act in an object store capacity. So the data, the actual data for the objects that were being stored are going to the hard drives, and then we use the NVMe devices for 3 different purposes. The Ceph OSD has kind of a journal that it uses for kind of transactional atomicity underneath the covers. Carved out a portion of it to use a caching technology from Intel called Intel Cache, and that's used to puts instrumentation into the VFS layer of the kernel, and then can identify XFS metadata and store that metadata on the cache device instead of having to store it onto the hard drive. And then finally, taking a portion of the flash and using it to run additional OSDs, which is the storage process in Ceph, that we could then use to store the bucket indices. So, if you have a bucket that has a number of objects in it, there's an index, so that if you say, show me the objects that are in this bucket, that list is maintained in a bucket index. And in this case, we're having that stored on flash, so it's fast. Kind of the overall software stack on each of these hosts was, we would run 35 of the disk-based OSDs, so storage processes, 2 of the flash-based OSDs, which would be running on the SSDs. These were used for the bucket metadata. And then we have the Rados gateway, or the Ceph object gateway, that provides the interface, the S3 interface. So it's an interface that's compatible with Amazon S3. And then we run HA proxy just directly in front of each of the RGWs to kind of act as a connection shield sidecar. So the more macro view of this is, in the particular Tricep lab, we had 20 of these hosts that were running the storage processes and the object gateways. And then collectively they formed a cluster that had I guess it was 740 odd OSDs, and then they would provide kind of the equivalent of a private infrastructure version of S3 that you could use as a shared data context. And then above that, we had an additional 20 nodes that we used for running the various analytics tools. So we would carve them up into different collections. Sometimes we would run separate workloads in distinct sets, and some of them we would take the whole collection of 20 hosts and run larger workloads on them. So we kind of varied the technology that was used on the compute side, from just using upstream Apache Hadoop with Spark SQL or Hive, but then also using technologies like Presto, a query, massively parallel processing engine that came out of Facebook, and then Impala, which of course is kind of the query engine that is being touted by the likes of Cloudera. So kind of just to give a taste of some of the performance results that we saw from this, you can see that we saw similar performance when compared to HDFS, which was good because in the particular case of the Ceph object store, we're using erasure coding instead of replication. So instead of having 3 times the overhead, you're reducing that expenditure by half, because the code we were using was a 4.2 erasure code, so your overhead is 150% instead of 300%. So that's a significant savings on capital expenditure and operational expenditure when you're talking about petabytes and petabytes of data, and being able to do that with half the amount of equipment as you maybe had previously. So with that, I'll pass it back to Brent to kind of recap a little bit.
Thanks. So the net result of this Ceph lab inside of QCT, when the customers came to us, they said the gains in agility that we would get in being able to effectively spin up new analytics clusters without having to hydrate data into those clusters, those gains in agility that we would get, even if we got anywhere close to the performance, we would absolutely do this. Again, it's multi-tenant workload isolation with shared data context. And so what they were looking for was anywhere close from a performance standpoint to what they would get with native HDFS, because again, HDFS in its traditional mode is not shared in between clusters. So that's why the results that in Kyle's slide that he just showed were so compelling to these customers, which have then moved on into production, is because the gains they got in agility were corresponded with very comparable performance. So the summary then, coming back to where we started off, how do you POC at scale workloads at scale? That's a hard problem, and quickly. Through Red Hat working with QCT labs, gave our customers that experience to give them the confidence that those workloads, in this case, a modern data analytics pipeline running on top of a shared data context provided by Ceph Object Storage, worked. So thank you, Gary, for allowing us to use those labs. Anyway, so that's all we have. We have a few minutes left for questions. Any questions at all, except for from George? No questions from George.
Do we see any performance gain in this case compared to bare metal?
In some cases, so it's the comparison is versus HDFS. So in some cases, yes, there are performance gains. But again, when you look at, there are 3 things to look at. The most important thing to look at is if you're in an environment where you have multiple analytics teams, Let's say you have 5 data science teams, 2 data engineering teams, and 3 data analytics teams. And each one of those teams has their own cluster. If they need to have access to shared data sets, you're forced to replicate that data across. So if it's a 10 petabyte data set, you have to replicate 10 petabytes across 10 clusters. So you're buying 100 petabytes, and by the way, you're not just buying 100 petabytes because it's by default in HDFS, it's 3x replication. So you're buying 300 petabytes for a 10 petabyte data set. That's the higher order problem here. That's what the customers we're working with, that's what caused them to look at this architecture. So it was not, they weren't looking to get, can I get 20% more performance? They're looking to save an order of magnitude in CapEx as well as OpEx. And the second thing they're looking to solve, so that was the first thing. The second thing looking to solve is agility. In the paradigm in AWS, EMR or just running CDH or HTTP on top of EC2, you can spin up your analytics clusters very quickly without having to hydrate your data set into the cluster, because those clusters use AWS S3 as the shared data context instead of, in many cases, instead of HDFS. So the agility gains were the second big thing they're looking for. So the least important thing was for the customers we worked with, the least important thing was performance. Performance had to be acceptable, because if it could do the other, performance was acceptable, the gains they would get in the other 2 areas were so large, that's all they were looking for. And in fact, that's what was illustrated on the previous slide, was with those 2 gains in the top 2 categories, the performance indeed was in many cases comparable, in a few cases a little bit better, a few cases a little worse, but was acceptable. That's what allowed them to say, hey, because of the gains in the first 2, this is a win. So that's the answer to the question. Any other questions, please? Kyle, how far can this scale out? Are you talking about Ceph in general, Ceph object storage in general?
Yeah, we have a number of customers that are managing well into the tens of petabytes with Ceph cluster. Yeah. Sorry? Right. Yeah. Like in this case, the Tricep lab was 20 machines. So that's 40 RU. So that was 5 petabytes in a rack. So yeah, I mean, you can get a lot of storage, and you can get a 20 petabyte store in 4 racks in raw capacity. Yeah. A 100 petabyte? Yeah, you could go to 100 petabyte. There is probably some architectural considerations that you would do in order for kind of reaching that next magnitude of scale. We tried a number of various tools. So we did experiments with both just kind of the traditional, Hive queries running on a Yarn cluster, but then also using Spark SQL in a Yarn cluster, and then also using a collection of hosts that are running either Presto or Impala. Anybody else? Well, thank you.
Okay. Yeah, thank you. So that's the very good collaboration between the QCD and the Ray Hay. So based on that, actually we know that the real testing makes a difference. So in addition to the so far the big data analytical kind of the testing in the Ceph. Actually, as we are extending the cover the other testing. So all in all, that we are under the same testing program we call the Tricep, which eventually provide, as I mentioned, the different use case. Some of them is testing for the file, some of them testing for the IOPS. We will gradually open those kind of the testing and offer to the customer. So you gotta have any testing in mind, some POC in mind. Discuss it with let's see how we can arrange it for that. And thank you for your time. Thank you, Brian. Thank you, Kyle.